Chapter 5, Exercise 5.63, Part A. Determine the molecular geometry of IF4+, iodine tetrafluoride cation. Iodine has 7 valence electrons, but with this plus sign, this iodine has 6 valence electrons. It's going to form 4 single bonds with the 4 fluorine atoms, and then there are 2 extra valence electrons as lone pair electrons. So surrounding this iodine, we have 1 lone pair and 4 single bonds. The electron geometry is trigonal bipyramidal. However, in this question, we need to determine the molecular geometry. So among the 5 electron groups, 1 is lone pair. If we ignore the lone pair, the molecular geometry becomes seesaw. Alright, so let's take a look. 5 electron groups, right? And then we have trigonal bipyramidal electron geometry. The molecular geometry is different because of the lone pair electrons. Choose the correct sketch for IF4+. It's this one with 1, 2, 3, 4 bonds, and then lone pair here. You have 2 lone pair electrons over here. Submit. Part C. Determine the molecular geometry of SBr6, sulfur, hexabromide. Sulfur has 6 valence electrons, therefore it forms 6 single bonds with the 6 bromine atoms. No lone pair electrons, just 6 bonds, 6 single bonds. It has to be octahedral. Because this octahedral allows sulfur to separate the electron groups as much as possible. Submit. Part D. It's easy, just octahedral over here, up, down, left, right, front, back, 6 bonds. Oh, yeah, it should be this one. Sorry about this. It's when we have a 3-dimensional structure, we use wedges for the bonds that stick out of the plan and the hash bonds behind the plan. Determine the molecular geometry AsF5 using the bonding conventions in this part of section 5.9. This is arsenic. Arsenic has 5 valence electrons, so this atom forms 5 single bonds with the 5 fluorine atoms. There are 5 electron groups, no lone pair electrons, so trigonal bipyramidal. And also in this case, the molecular geometry is the electron geometry. This time I need to be careful, so this is pointing at us, this hash line is pointing away from us. 5 electron groups. Part G. Determine the molecular geometry of chlorine pentafluoride. Chlorine has 7 valence electrons. and it forms only 5 single bonds with the 5 fluorine atoms. Therefore, we have 1 lone pair plus 5 bonds. The electron geometry is octahedral because we have 6 electron groups. When we are talking about molecular geometry, we need to ignore the lone pair. We hide the lone pair. There are just 5 bonds. It's gonna be square pyramidal. So because again, when we are talking about the molecular geometry, we do not take the lone pair into account. Alright, and now the sketch of ClF5. Alright, so we're gonna choose this one. Actually, there's a lone pair below chlorine. There's a lone pair below chlorine. It's just in the molecular geometry we do not plot the lone pair electrons.